Welcome to DataFIX, automated tools for data review and substitution. DataFIX is a tool that enables fast and efficient data preparation for data quality management. Its focus is on real-life online datasets as sensor data or online service when dealing with time series and missing data. Existing data cleaning platforms lack automation and require high levels of expert interaction. Identifying and correcting erroneous data is expensive, requiring analysts' expertise and ad hoc solutions. The proposed technology solution is DataFIX, developed as an interactive web application. DataFIX provides automated data cleaning and substitution without workflow design, and data visualization and data correction options for a variety of data types. DataFIX serves as a proof of concept for automated data review and substitution, bringing together advanced statistical solutions for unsupervised learning, model and domain independent. The DataFIX demonstrator is organized in 3 modules: data correction, time series anomaly detection, and data substitution, addressing various data types: numerical, categorical, and time series. Data cleaning identifies bad formats for datetime and reshapes these automatically to standard date formats. Mismatched attributes are identified and replaced by NA. Anomaly detection performs automated detection of outliers, change points and breakpoints along with their location in data. Data substitution imputes missing data for multivariate numerical and categorical data as well as for time series. Interactivity, a flexible interface, automated visualizations, results available for download at any time through the process are just a few of the features offered. Next, I'm going to show the various steps required in order to use the DataFIX demonstrator. To start, we press on Start and we're presented with a screen where you can browse our computer in order to upload a dataset. Here we're going to upload the air quality dataset. And pressing on Show Data, we are presented with a table containing the data and with an interactive plot which presents the number and percentage of NAs in each column. We are also shown the dataset structure and the columns to proceed, of which we can choose the columns we would like to keep in our analysis. By deselecting the column, we remove columns from the dataset considered for analysis. We are also given an extra column, X, which is the actual index of the dataset. It is important to keep this column to enable data analysis as a sequence. Pressing on Continue, we are presented the data overview, which contains data summary for each column with various parameters and a plot, which is a histogram for numerical data and a bar plot for categorical data. In the Manual Correction sub-tab, we can merge columns to create a date-time column when these columns are numerical. For example, if we have numerical columns representing days, we can choose these. And numerical columns representing months, we can choose these. And pressing on Done, we obtain a new column which contains the actual date given by merging the numerical columns day and month, and we obtain a column without NAs in the dataset. We can also proceed to select known anomalies and select a column, for example, wind, and can define bad data as values or as an interval. For example, here we select interval between 15 and 20, and when we press Done, in the column wind, obtaining now 5% NAs introduced, defining bad data. We can see that the initial NAs are now in a different color. Pressing on Continue, we move to the Time Series Anomalies tab, where we're presented with a screen with a number of selections between various types of algorithms. For a time series without NAs, for example, numerical columns with no missing data like temperature, we can perform anomaly detection using various algorithms like Anomalize, CPM, or QCC. For example, choosing Anomalize, if we change the parameters alpha and the percentage of points that are allowed for analysis, we can obtain a number of anomaly points, which are going to be shown in our observations. We can apply other algorithms, for example, CPM, and we choose again temperature, and we can see that in this case we do not obtain any anomaly points, or QCC, where for the column temperature we obtain a number of outliers represented in blue on the scatter plot and a table with anomaly points. We can also use sequences complete because the date-time series is also a type of sequence, and selecting a numerical column, we have access to a number of other algorithms, for example BFAST, which is prompting us to select a seasonality type between non, domi and harmonic. For example, here we choose none. And for the column temperature, we can also scan across the dataset in order to analyze a batch of data. We can choose starting point in our analysis and the number of data lines and the number of breaks. It is important to notice that the larger the number of data lines selected and the number of breaks selected, the analysis will take a longer time. Here, pressing on Done, we are presented with a table with anomaly points, with a plot containing the noise, the trend of the breaks in noise and the data, and also with a scatter plot which represents the data and the anomaly points as blue dots. To perform data substitution for time series, we can choose the imputes method, which allows us to use the merge date column you obtained before or the index column. We can choose from numerical columns the columns which have NAs, for example ozone. We can apply a number of imputation types, 8 imputation types: random, last observation carried forward, linear interpolation, weighted moving average, and so on and so forth. For example, choosing random imputation, we are presented with a table with imputed data as random data and the scatter plot of data with random imputation points as red dots. For last observation carried forward, the imputed data is shown as straight lines across the intervals where the data is missing. For linear interpolation, the imputed data is shown across a straight line connecting the ends of the intervals with missing data. We can also apply weighted moving average, which performs a different type of imputation result across the data set. To give an example of data substitution in numerical and categorical columns, I'm going to upload the air quality data set where the column months has been modified, becoming a categorical column. We can see in the data structure that column months is a character type. We can move forward to perform autocorrection. We can choose either MDY or DMY. Both choices are valid because in this case we do not have a datetime column. And we can move forward. We can perform anomaly detection using sequences complete or with NAs. For example, we can have access to a number of time series anomaly algorithms, CPM, BFAST, QCC, or Mahalanobis. For example, we choose Mahalanobis, and because it is a multivariate algorithm, we can choose 2 columns, for example, wind and temperature, to find common outliers in these variables. We obtain a table with anomaly points and a number of outliers which correspond to both variables represented as scatter plots. We can continue to the data substitution tab where we can choose the method MICE, multiple imputation by chained equations, which performs multivariate imputations with 5 imputation choices per variable, choosing a numerical column with an A, ozone, and pressing on Done. We obtain a table with 5 imputation options, including the mean imputation, and a column with initial data for ozone. The probability density distribution of actual and imputed data, we can see the various changes in such distributions, and the data after imputation for imputation number 1, along with the initial data table which has the column for ozone already imputed with imputation number 1. The best imputation number is imputation number 4 according to Jensen-Shannon divergence method, and this will match best the probability density distribution of initial data. We choose to select the imputation number 4 to be used as imputed data, and we can see that in line 5 we have a missing data, and the corresponding value for this data in imputation number 4 is number 13, and this number 13 is imputed in the column ozone in line 5 in the final data set. Therefore, this data can be submitted to downloads, and we can retrieve it from the download tab in the imputation section. In the case of categorical data as the month column, we obtain also a table with 5 imputations and the initial data. We can see there are missing data points, and we also obtain the probability density distributions of actual and imputed data as proportions of levels represented as bar charts, and data after imputation for imputation number 1 with red dots representing imputing data, and the initial data set where the column months has been already imputed with imputation values from imputation number 1. We can also replace these values with the best values indicated by Jensen-Shannon divergence. We obtain the best possible match with the initial data for column months. At any time, we can submit again data to downloads, and we can retrieve the data from the imputation section in the download button. There are numerous features and options for data correction, time series anomaly, and data substitution, which we encourage you to use and explore. Thank you for your attention.